Today I want to talk to you about limiting reagent. This is a classic chemistry problem and one you will see on many exams, mine included. Here is a classic problem. We have a combustion reaction, hydrocarbon being combusted in oxygen to produce CO2 and water. We have this balanced equation and we are told that 40 grams of C6H10 are reacted with 100 grams of O2. We want to know A, the limiting reagent, B, how many grams will remain of excess reagent after the reaction is over, and what is the percent yield of our reaction if we are told that the actual yield of CO2 is 91 grams. Let's get started. First, we want to get organized. We want the molar masses for our reactants and for our product, CO2. Why CO2? Because we were given an actual yield number for CO2, so that's the one we're going to focus on. The other thing that is crucial is our mole-to-mole ratios. These are derived from the stoichiometric coefficients of our balanced equation. This balanced equation tells us we get 12 moles of CO2 out for every 2 moles of C6H10 that we put in. And alternatively, it tells us that we get 12 moles of CO2 out for every 17 moles of O2 that we put in. Very different. Worth noting that and crucial to use it in our problem solving. We also need a strategic plan. We are going to go from grams of reactant to moles of reactant to moles of product for both reactants. How do we get from grams of reactant to moles of reactant? Well, of course, we use the molar mass, and we get from moles of reactant to moles of product using the mole-to-mole ratio. We have to do this for both reactants. Once we have done that for both reactants, we can compare how much product is generated in each case. Whichever reactant produces less product is limiting. Why? Because after the limiting reactant is used up, no more product can be generated. This is the rationale behind less product. So let's get started with this problem. We know we have 40 grams of C6H10. We made sure we knew all the molar masses. So we're going to say, okay, 1 mole of C6H10 for every 82.143 grams. Then we use our all-important mole-to-mole ratio, 12 mole CO2 for every 2 mole C6H10. When we do the math, we will find out that we produce 2.922 mole of our product, CO2. We do this again for oxygen. 100 grams of O2 times 1 mole O2 per 31.999 grams times, in this case, 12 mole of CO2 for every 17 mole of O2. Again, we do the math, and this time we get 2.206 mole of CO2. When we compare these two, clearly it is 2.206 that is the lesser amount of product. Therefore, oxygen gas is our limiting reagent. We have done it. We have figured that out, and we will use some of this data for the next problems. Okay, so now we can figure out excess reagent. And what we want to do here is recognizing the fact that we produce 2.206 moles of CO2, or that we could only produce 2.206 moles of CO2, we want to now find out how much C6H10 did we really need to generate 2.206 moles of CO2. And in order to do that, we're going to have to work backwards from our product CO2 to find out how much C6H10 we really needed. Okay, so let's do that. We're going to take 2.206 mole of CO2, and then we're going to use the mole-to-mole ratio in a working backwards kind of way. We're going to say, okay, we have to put in 2 moles of C6H10 for every 12 mole of CO2. Moles of CO2 are going to cancel. If we were to stop at this point, we'd have how many moles of C6H10 that we actually needed, but it's most useful for us at this point to have grams. So we're going to say 82.143 grams per mole of C6H10. And we're going to find out that this actually equals 30.2 grams of C6H10. How much did we actually have of C6H10 to react? Well, you may recall that we had 40 grams. So we're going to take our 40 grams of C6H10. We're going to subtract the 30.2 that we actually genuinely needed to use for this reaction. And we're going to find out that therefore we have 9.8 grams of C6H10 that should be left over. Okay. Finally, we can do part C, percent yield. There's a couple pieces of data that we need from our calculations and from the problem. We know that the maximum amount of product we can make is 2.206 moles of CO2, and we're told in the problem that the actual yield is 91.0 grams. So, since we need the ratio of actual yield to theoretical yield in grams times 100%, we're going to go from moles of CO2 to grams of CO2, which is our theoretical yield. This is if everything in the world is perfect, which it never is. So we're going to go from 2.206 mole CO2 times 44.01 gram per mole CO2, and that's going to give us a gram amount, which is actually 97.1 grams. Now we're going to deploy our formula. Actual yield is 91.0 grams. Theoretical yield, which we just calculated, is 97.1 grams times 100 to get the percent. And we're going to find out that we did fabulously well in this, conducting this reaction. We actually got 93.7% yield, a number upon which any chemist would congratulate themselves. Okay, so that's it for limiting reagent. If you want more practice, there are a ton of problems online. Again, this will be on the exam. Take advantage of this video and master it completely.